Hello, everyone, and thank you all for joining us for this session today. In this session, we are going to talk about shift left in container adoption application development. My name is Shun Tanai. As an account solution architect of Red Hat, I work for Japanese financial institution customers, especially for Sumitomo Mitsui Financial Group, SMFG. And I speak together with Mr. Chaudhary from the Japan Research Institute, JRI, the IT company of SMFG Group, and single Red Hat OpenShift specialist solution architect. So firstly, we will talk about the challenges faced by Japanese customers in implementing shift left and our approach against them as we consider. And after then, talk about the journey of shift left implementation that Mr. Chaudhary's Samurai team is working on. So nowadays, as many enterprises have to develop more and more software and applications, they perform various security tasks in their development process. And many customers face a problem of the security testing results at a later stage of development. This sometimes produces problems such as redevelopment and release delays, and sometimes creates engineer frustration. So as you may already know, many books or articles or authorities say shift left it, but shift left or shift lifting encourages earlier detection by implementing security tasks into each development stage, kind of code, build, and other steps. And not only that, developers need to maintain speed, frequency, and stability in their software supply chain. So to that, many people also think, oh, we should be DevSecOps, or we need to more collaborate with dev team or ops team or security team. But however, this is a difficult challenge for many Japanese enterprises we work with daily. Over the past few years, many customers in Japan have been working on developing and operating applications on containers, but they still have not been able to overcome their worries or challenges about security. In addition, many customers have started DevOps initiatives, but many fear their organizations need more skills, capabilities to implement DevOps. This figure shows the Japanese challenges. Specific issues differ from company to company, of course, and Mr. Chaudhary will explain SMFG details later. But in general, there are some common organizational or cultural issues related to software engineering that exist in the Japanese enterprise. One is the issue of organizational silos. As a typical example, as shown this figure, in Japan, application development, infrastructure development, and ops organizations are separated from each other, and each depends on deeply technical partner, such as a system integrator for human resources and skills. This barrier is between the laws of each department solid, and it is common for there to be strict protocol and time-consuming workflows for interaction between teams. Many projects are also developed in a waterfall model. And in addition to this, department with security responsibilities exist independently of this development team. So there is a lack of security engineer or a lack of knowledge and skills about software security in the development team. As I just mentioned, many Japanese companies are facing such major difficulties in implementing DevOps or DevSecOps practices. Therefore, they need to consider a realistic approach to such challenges. How can they bring themselves closer to achieving shift left and DevSecOps in this environment? So, yeah, I'll switch with Singo from here. He will now talk about the approach to these problems.
Okay, thank you. Yeah. All right, hello everyone. My name is Shingo from the OpenShift product SA. So I am very surprised that to see a lot of Japanese people in this room. So I wonder that why I'm speaking the English. So, so okay. Let's get started. So today I'm going to introduce you to the DevSecOps in Japan. So how to run the application more securely on the OpenShift. So once you have adopted the DevSecOps in culture, so what is the desired state of the team's collaboration? So once in place, so security teams are involved in the conversation early and often, and the teams actively communicate to keep the security at the forefront. So modern the teams started using the appropriate tools to help them manage the security and so on. So, but we know that this is a desired state, that's only. So, but it won't turn out the way we expect. So, as Shin said earlier, so the enterprise Japan customer is struggling with the team collaboration. So in general, so many teams tend to operate in their own worlds, you know. So with customized tools and information resources and so on, so that's called the silos. But the silo has now become the biggest impediment to agility and quality. For example, security teams often announce to us, we found that our code, we found that our code on the library with a vulnerability. So that is main discussions, but before the 3 days is the biggest problem on the launch the services. So and we said that so that's the story of life. So it's a common topic not only for Japan but also all over the world. So problem is that we are not able to observe the security and quality until just before the release. So we have to think about how to improve the security without disrupting the correct process and team structure. So this is a real world of the DevSecOps. We start by taking the security and one step further. So we do that by shifting the security and quality to left in the pipeline. So and then we keep the teams and their role as the same. So before the security teams, they check the vulnerability prior to release. But that confirmation has already been checked automatically in the environment process. In this way, so security doesn't become the responsibility just only one group. So it won't. I want you to keep in mind that so security responsibility is that become everyone's responsibility. So this is a real goal of the DevSecOps. So let me dive into the reference architecture. As you can see, this is a hybrid cloud security pattern in Red Hat. So with this pattern, you can build security pipeline while developing your application. So the key is to separate the cluster in the hub and spoke. The hub cluster is responsible for the centralized management of the security and quality. So This design shows security teams to monitor them by the consolidated interface. So Red Hat provides advanced cluster security and QA on the hub cluster, also included in the supply chain. So we announced today's morning. So however, even if you use these other tools, so this structure is also true on the vulnerability detection. So meanwhile, the Spoke cluster can focus on the building the pipelines on each environment. It doesn't matter if the cluster continues to grow. So because DevOps cycle are each Spoke cluster without security. So by this way, the consumer focusing on the what is being delivered, not how. So now let me bring you back to the use case. So today we have invited Mr. Chodori. So Japan Resource Institute, one of the most famous bank in Japan. So as you can find a lot of insights and his success story. So please welcome him.
Thank you. Thank you.
Thank you.
Good.
Next.
Okay. Hello, everyone. My name is Tagdi Chaudhary. I'm the Chief Digital Strategist and General Manager at the Japan Research Institute, in short GRI. Thank you for attending the session, and I appreciate your interest in the topic I will be presenting today. The topic is about shift left. That is very crucial for everyone involved in delivering digital services. I will be explaining how shift left can help us to deliver services that are stable, scalable, secure, and resilient, particularly on OpenShift. I'm not used to presenting in English. I'm feeling super nervous. Is there anyone there who is also feeling nervous? No way, right? Yeah. Okay. Let's take a quick look at the agenda on my presentation. I will provide a brief overview about my working experience, as well as a quick introduction to my company and my digital team. I will discuss about our DevSecOps journey, including how we got started and the various practices and technologies we use to accelerate the digital service delivery. I will also share some KPIs of our digital team and showcase some strategic digital services of our company. About me, I'm married. I have 2 daughters, and I am also a proud owner of a cat and a guinea pig. In my free time, I enjoy cooking and watching Netflix movies and playing tennis. I started the computer science at a Japanese university, completed both undergraduate and master's courses. My professional career began at a Japanese telecommunication company. It's NTT Advanced Technology. I worked there as a software engineer. After working for about 5 years at NTT, I moved to MetLife, which is a US-based insurance company. I worked there as an IT architect. After working for 8 years at MetLife, I moved to AXA Life Insurance, which is a French-based insurance company, and I worked there as a digital transformation lead. Currently, I'm working in the Japan Research Institute as a digital transformation lead and promoting the DevSecOps culture. About GRI, a quick introduction about GRI. GRI was established in 1969. It's a subsidiary of Sumitomo Mitsui Financial Group, which is one of the leading financial institutes in Japan. As of March 2022, the GRI has 2,810 employees, supported by 5,000 subcontractors from partners. In terms of business, GRI consists of research, incubation, consulting, and IT solution departments, where I'm working for. The research, incubation, and consulting departments provide a wide range of services to any kind of institutions. These include publishing research and study results on macroeconomic trends, and providing policy recommendations, and supporting the numerous transformation, solving social issues, and providing strategic planning to implementation. The IT solution departments supports the Sumitomo Mitsui Financial Group's IT systems development and operation by promoting the IT strategy, implementing and managing the mission critical large-scale systems with a focus on high stability and resilience. A quick introduction to our digital team. The team was established in October 2020 to promote an autonomous in-house organization that leads from upstream business planning to downstream implementation and delivering new digital services. The organization consists of 5 teams: digital service discovery, digital service delivery, digital service platform, digital COE, API COE teams. As of today, the team consists of 79 people, including 70 employees and 9 subcontractors. It's a very diverse team, as it has many multinational bilingual employees from 10 countries. And the picture on the slide was taken during a hackathon event that was held by the team March this year. Now I will discuss about our DevSecOps journey. Before delving into the journey, let me provide you a brief overview of how IT development is managed in the financial institutions in Japan. In Japan, most financial institutions, especially the large ones, they do not have the in-house IT development and operation team in their IT departments. This is mainly because the IT team is typically seen as a cost center that does not contribute to the company's growth. As a result, the IT departments in many financial institutions in Japan are small in size, and due to the economies of scale and lack of economies of scale and expertise, the IT development tasks such as system design, implementation, operations are outsourced to system integrators. The IT department team mainly acts as a project manager and oversees the cost, quality, and service and schedule of IT project. Moreover, the public cloud platform are not widely considered reliable and secure in many financial institutions in Japan, mainly due to the absence of internal cloud experts. As a result, most of the services are deployed and managed in traditional data centers. Moreover, in many cases, especially for large projects, the system integrators, they outsource their work to multiple subcontractors to obtain more additional manpower and expertise, which often leads to increased complexity. And the consequences of this IT development approach include slower time to market and lack of ownership and commitment, vendor lock-in, and higher total cost of ownership. Under these circumstances, to deliver faster, cheaper, and of higher quality, and as well as stable, scalable, secure, and resilient digital services, our top management made the decision to break out of the status quo and initiate transformation by establishing an in-house digital team. Now let me provide a quick overview of our transformation journey. The digital team was established in 2020. Between 2020 and 2021, our main focus was on promoting DevOps and automation, particularly CI/CD practices with shift-left testing. Since 2022, we shifted our focus to promoting DevSecOps and adopted a shift-left security approach. When we established the team in 2020, we also formulated several policies for the team to promote the delivery of stable, scalable, secure, and resilient digital services. The policies are building and delivering cloud-native applications, mobile apps with agile development methodology, using fully managed container-based platform on public clouds, using fully managed mobile backend as a service platform for mobile apps, promoting DevSecOps culture by adopting shift-left approach, and automating the application testing, deployment, security, and monitoring. We have been taking several actions since 2020 based on these policies. I will share some of the major actions with you. In 2020, we recruited an external transformation lead. Yes, that was me, and launched a digital team with only 9 members. And we also mobilized 7 members from other divisions in GRI and recruited 7 external talents. We defined 9 digital roles and responsibilities to deliver to deliver the digital services. We also defined and standardized the agile process, adopted several development and operation tools. We implemented CI/CD pipelines. We also adopted managed PaaS platform, Observability Platform. I will provide further details of the highlighted actions in the upcoming slides. Between 2021 to 22, we mobilized 24 members from other division in JRI to strengthen the organization, and also recruited 23 external talents. We also adopted a mobile backend as a SaaS platform for our mobile application. We adopted the application security testing tool to promote DevSecOps. We defined the agile process to incorporate the shift-left security. Defined a proprietary maturity model to track and measure our team's growth. Last but not the least, we automated the log and performance monitoring process. Public cloud platforms and managed service play a crucial role as key enablers in delivering stable, scalable, secure, and resilient digital services. We adopted Red Hat OpenShift Dedicated platform to run and to build, run, and monitor our digital services. The Red Hat, is there anyone who is using the OpenShift Dedicated or ROSA on AWS? Okay, cool, thank you. So Red Hat OpenShift Dedicated platform is a fully managed platform which is provided by Red Hat, and is fully managed platform that is supported by Red Hat SRE, Site Reliability Engineers, 24/7. And it also provides, it's a one-stop platform that provides all the necessary features for application development, deployment, monitoring, and auto-scaling and backup, as well as a wide range of security and compliance certifications. This enables our software engineers to focus on designing robust architecture and writing high-quality code, ensuring the stability, scalability, and security in our digital applications. Moreover, it empowers our DevOps engineers to automate the application deployment and monitoring, ensuring the stability and security and resilience in our digital applications. Our delivery process, formulating a well-defined delivery process is crucial to ensure the flexible and stable delivery of digital services to production. Our delivery process is divided into 4 steps: plan, design, do. 4 iterative steps: plan, design, do, and deliver. In the plan step, we formulate the product vision, roadmap, and prioritize backlogs. This help us to set clear goals and set clear goals and prioritize tasks for the development process. During the design step, we focus on creating system architecture, designing the user interface, and defining the user stories. This step ensures that we have a solid foundation and clear specification for the development work. The do is where the actual development takes place. So we follow Scrum methodology to build, deploy, test code at do step, and in the delivery step, we perform the user acceptance test and non-functional test, and release the application to production. We also implement a Scrum and Kanban board to visualize our activities during the visualize our delivery activities. The board demonstrates that we have integrated a quality check point known as definition of done, in short DOD, at the completion of each step to ensure the stable delivery with high quality standards. The do step can only proceed if only the plan of, if the definition of done for plan and design steps has been met. And we also redefine the do. We also define within the do step we have defined 2 sub steps: build, deploy, and test. Build and deploy and test can only be initiated if the definition of done of build sub step has been satisfied, and so on. Now let me explain you how we implement the shift left approach in our delivery process. Our shift left, our delivery process, that incorporates the Scrum methodology, can be categorized into 2 main activities: sprint activity, release activity. During the sprint activity, we follow a 2-week development cycle that involves various activities. We start designing with application and database design, following by coding, conducting unit test, which is common in the agile development practice. On top of that, to implement the shift left, we also perform the system integration test and application security test during the sprint activity. Moreover, we also assess the performance at the unit level to ensure that the application and the API, response time of the application and the API meet the business expectation early in the development process. And during this release activity, we perform the user experience test as well as non-functional test, including performance testing, penetration testing, recovery testing. Moreover, we also perform change management and release review to ensure a smooth release to the production. Now, as I explained in the previous slide, that we implement the shift left testing in our sprint activity. Now let's delve into who performs the shift left testing, what types of testing are conducted, what type of tools and practices we use to implement the shift left testing in the sprint activity. Our software and testing engineers are responsible for carrying out the shift left testing during the sprint activity. They perform unit test, functional system integration test, regression test, end-to-end test, cross-browser and cross-OS and browser test, application security test. As I explained, they also perform the performance check at unit level during the sprint activity. And we use, as for tools and practices, we use the test-driven development practices in implementing the test-first approach. We use Selenium, Appium, Playwright for test automation, for regression test automation, browser stack for cross-OS browser test, contrast security for application security test, Instana for performance check, and SquashTM as our test management tools. By implementing these practices, testing practices and tools early in the development process, we can identify and address the issues and vulnerabilities at an early stage, which are leading to higher quality standard and cost reduction. Now I will explain how we implement the shift left security using contrast assess during the sprint activity in our delivery process. Let's take a quick look at the contrast assess architecture. Contrast assess is an interactive application security testing platform that utilizes the agent technology to detect the vulnerabilities in the applications. The intelligent agent are embedded directly into the source code and instrumenting the with multiple sensors to detect the sensors to monitor the behavior and detect vulnerabilities based on multiple indicators. The contrast agent reports the detected vulnerabilities to contrast server. The contrast server displays a list of vulnerabilities on the found on the application source code, as well as any vulnerabilities in open source libraries the application used on a user-friendly dashboard. It also provides recommendation for countermeasures and remediation methods. So during the sprint activity, our software engineers they use mockup to run the application on their development PC, typically the MacBook. They also run the application on the development server in OpenShift after integrating merging the modules and components and doing another round of test. In both cases, while the software engineers testing the application, the embedded contrast agent detect the vulnerabilities and send them to the contrast server. And software engineers then log into the contrast server and review the details of the vulnerabilities and fix the source code based on the remediation methods provided by the contrast server. Once all application bugs and vulnerabilities are fixed, the application is deployed to the QA server and staging server, where our test engineers and business engineers conduct test. While they are testing, again, the contrast embedded contrast agent, their contrast agent detect vulnerabilities and send them to the contrast server. If any bugs are found on the QA server and staging server, the test engineers they create a security ticket and assign them to the software engineers. So by integrating this application security testing and DevSecOps tool, contrast security, we at an early stage of in the early development process, we proactively identify and address vulnerabilities, fostering the shift left to security and enhancing the overall security posture of our applications. Our observability platform, continuous monitoring plays a crucial role as a key enabler in delivering stable and resilient digital services. So we adopted the Sustana platform, which is a managed IBM observability platform to monitor our cloud platforms and cloud native applications in production. Let's take a quick look at the architecture of Sustana. Sustana utilizes the agent technology to monitor both application and infrastructure log, both application and infrastructure, so Sustana automatically installed in the worker nodes in OpenShift with using the OpenShift daemon sets. Once the installer get installed, it automatically monitor the CPU and memory usage as well as all the applications running inside the pod. They continuously send the application and performance metrics along with event trace information to the Sustana backend server every second. The Sustana backend server receives the data from Sustana agent and display a visual metrics on a user-friendly dashboard. Moreover, Sustana backend server generates alerts when a predefined metrics thresholds such as latency, response times, number of errors are exceeded. These alerts quickly notify engineers who can then log into the Sustana backend server and review the alerts of the review the details of the alerts. The engineers also leveraging the trace information. The engineers also can quickly identify the root cause, identify and redress the root cause of any errors that may arise. We have also implemented a monitoring architecture that enables us to continuously that enables us the continuous log and performance monitoring, ensuring the performance and the availability of our infrastructure and applications. Let's take a closer look at the monitoring architecture. We utilize the EFK, Elasticsearch, Fluentd, and Kibana provided by OpenShift clusters logging operator. All our applications running in OpenShift, they write logs to console, terminal console. The Fluentd collect those logs from console and forward it to the Elasticsearch. And Elasticsearch, which then indexes the logs for easy searchability. Our software and offset engineers use Kibana to access and analyze logs. Moreover, Fluentd also forward logs to Amazon CloudWatch, triggering AWS Lambda functions that filters out the errors from logs and send them to our ops engineers using AWS simple notification service for immediate attention. Simultaneously, the error logs are also stored in the Amazon S3 bucket, which is integrated with our legacy monitoring tool, which is used by our 24/7 operation team in data center. Upon receiving error notifications, our 24/7 operation team escalate them to our digital teams, on-call ops engineers, even out of business hours. Moreover, we have, on the left side, we have configured the Sustana server. Sorry, I don't know. The cursor is. Okay, yeah. We have configured the Sustana server to store the application and infrastructure platform alerts in AWS S3 using API gateway and AWS Lambda. This setup ensures that our 24/7 operation team receives notification about performance alerts and quickly escalate them to our digital teams, on-call ops engineers, even outside regular business hours. With this architecture in place, we maintain the continuous. We maintain the log and performance. It enables us to maintain the log and performance metrics, ensuring the availability and performance of our application and infrastructure at all times. Okay, I have only 8 minutes. Let me provide you a brief overview of our delivery environments and CI/CD pipelines. We use 4 delivery environments: Dev server, QA server, staging server, prod server. For Dev server is fully managed by software engineers, QA server fully managed by QA engineers, staging and production server are fully managed by ops engineers, ensuring the segregation of duty. We have implemented CI/CD pipelines into each delivery environment. Our development environment, the CI/CD pipeline of our development environment is triggered when a merge request is approved by software engineers. The pipeline then proceed to check the source code quality and coverage using the SonarQube. It also runs automated unit test script and checks the vulnerabilities. After, if the result is satisfactory, the pipeline then triggers the image and building deployment webhook, which is provided by the OpenShift. And after the successful completion of the CI/CD pipeline, the application is deployed on the development server, where our software engineers validate the changes. As I explained, software engineers also check the application's vulnerabilities using contrast security dashboard and performance metrics using the Sustana dashboard. Our CI/CD pipeline is triggered after our software engineers merge changes to the test branch. In addition to the dev CI/CD pipeline, the QA CI/CD pipeline runs a automated test script for regression check. After the successful execution of this platform, of this pipeline, the application is deployed to the QA server on OpenShift, where our test engineers perform the manual integration, functional, and regression test. The CI/CD pipeline for our staging and production environment is triggered after software engineers merge the changes to release branch. The content of the pipeline is same as the QA pipeline, but it requires intervention by ops engineers. As I explained, that the development and staging environment are strictly managed by the ops engineers. After the successful execution of the pipeline, of the CI/CD pipeline, the application is deployed in the staging environment, where our business users conduct the user acceptance test. Upon completion of the UAT and the change management, security reviews, our ops engineers trigger the pipeline that promotes the container image from the staging server to the production server. Let me share some KPIs of our digital team. As mentioned, we started only with a few engineers. As of today, we have 49 engineers on board. Our 44% of our engineers are cloud certified, demonstrating our commitment to cloud expertise. And over the past 3 years, we have delivered 20 cloud native applications and microservices to production. Our current maturity index stands at 63%. Our ambitious goal is to achieve 100% maturity by 2026, positioning us as a unicorn in the digital industry. We pride ourselves on releasing into production within a time frame of 1 to 3 months. We have implemented 74 CI/CD pipelines in our delivery environments, and we have maintained a flawless record with no major or incidents or outages in the past 3 years, highlighting our strong commitment to stability and resilience. Now I will showcase Sumitomo Mitsui Banking Corporation's non-financial digital services that our digital team designed, built, and delivered from scratch. The first product is Adult Guardianship Supporting Service. The solution, the digital solution aims to address one of the significant social issues in Japan, and that is adult guardianship. It is a B2C digital subscription service designed to alleviate the management burden faced by the adult guardians. The service provides assistance in handling the income and expenditure of adult wards and streamlines the process of submitting reports, including various documents, to the family court on a regular basis. We have successfully delivered the application to production within a time frame of 5 months. This marked the first product released delivered in 2020 after establishing the in-house digital team. The application comprises with a backend for a front-end component, BFF, and multiple backend APIs and SQL, NoSQL databases. The application is run on Red Hat OpenShift Dedicated platform on AWS and is continuously monitored by Sustana. It is important to highlight that during the initial release in 2020, the shift-left security approach was not yet implemented, and consequently, several critical and high severity of vulnerabilities were detected during the penetration test phase in our delivery process. As a result, we had to postpone the release schedule by few weeks to address and rectify or fix those vulnerabilities. The second product is Sustana. It's a hybrid of sustainability and analytics. The digital solution aims to support corporate clients in simplifying and accelerating their decarbonization journey. It's a B2B digital subscription service that empowers corporate clients with complex supply chains as well as small to medium sized enterprises to accurately calculate and visualize greenhouse gas emissions. Additionally, it offers valuable insights and actionable recommendation to effectively reduce greenhouse gas emissions. We successfully delivered this service to production with a time frame of 5 months. The service has the same technology stack as the adult Guardianship, with addition of serverless technology for cost effective, to reduce cost. Yes, and we developed the service with shift left security approach. As a result, no showstopper vulnerabilities have been detected during the penetration test in the release activity, and ensuring a smooth release to the production with high levels of stability and security. The service was recognized for its excellence excellence technology, and received the prestigious Technology Excellence Award from Singapore Business Review in 2022. So this ends our presentation. Thank you for your time and attention. It seems that we have run out of time because I talked too much. I apologize for the inconvenience caused by this. However, we will be available just outside the room for a few minutes. So if you have any questions, please feel free to approach to us. Thank you for your understanding. Thank you.